All right, this is the video on solving absolute value equations. So first, a little bit about absolute value equations. It says solving absolute value equations is almost the exact same thing as solving regular equations with one major difference. In most cases, you'll have two solutions. Let's remember why absolute value equations are V-shaped, right? And we're looking to solve for x. And so we want to know what x is equal to, and we want to know where this graph intersects what I'm looking at right here. So like this is where absolute value is equal to 5. It's right here and right here, so there's two solutions. The places where it would have no solutions, here, and the place where it would have one solution, right there. All right, so in most cases, you're gonna get two solutions with the equations that we're giving you. Okay, so we know that when x is equal to 5, the absolute value of 5 is also equal to 5. So what it's saying here is that when I plug in 5 here, the absolute value of 5 is 5. But we also know that the absolute value of -5 is equal to 5. Why is this true? Because the absolute value is the distance from 0, right? So both 5 and -5 have a distance of 5 from 0. So therefore, the absolute value of 5 and -5 is 5. So when you plug it back in, they both work as solutions. So how do we solve an absolute value equation? What we're going to do is we have to isolate the absolute value. So on one side of the equation, you have to get the absolute value by itself, and then you're going to split it into two separate equations, setting one equal to the solution, the positive solution that it started off with, and then setting one equal to the negative, the opposite of that answer. So for example, let's look at all of these. It says in these first examples, notice how the absolute value is already isolated. So if you look on the left-hand side of all of these equations, it doesn't matter if it's the left or right. The absolute value is already by itself, so we're ready to solve this, okay? So if you think about it, whatever's in here, I want it equal to 24. And we know that the absolute value of 24 is 24, but we also know the absolute value of -24 is 24. So what we're going to do is we're going to take whatever's inside that absolute value, set it equal to 24, and then also set it equal to -24, and then solve each of those equations. So solving the first one, subtract 12 from both sides. We have 6x is equal to 12, divide by 6, and we get x equals 6. The second equation, subtract 12 from both sides. We have 6x is equal to -36, divide by 6, and we have x is equal to -6. And look at my math over here. 12 divided by 6 is 6. What? No, it's not. It's 2. I'm not starting my video over. I found it myself. All right, I could also find it when I go to check my solutions. So if we plug in 2 right here, 6 times 2 is 12 plus 12 is 24, and the absolute value of 24 is 24. And when we plug in -6 for x right there, 6 times -6 is -36. -36 plus 12 is -24, but the absolute value of -24 is +24. So there we have our two solutions. Okay, now the only time that you are going to get one solution is that if you're setting it equal to, if the absolute value is set equal to 0, because you can't set an equation equal to positive and -0, because 0 is not positive nor negative, okay? How are we gonna have no solutions? You'll see that in problem number 6, and we'll talk about it when we get there. All right, so whatever's inside this absolute value can be 14, or it can be -14 and still be true. So subtract 6 from both sides. We have -2x is equal to 8, divide by -2, and we have x equals -4. Subtract 6 from both sides. We have -2x is equal to -20, divide by -2, and we have x is 10. So there's our two solutions once again. All right, next one right here, whatever's inside there is equal to 42. So whatever's inside of there has to be equal to either 42 or it could be -42. And that'll still give me the absolute value as being 42. All right, add 2 to both sides. 8x equals 44. Divide by 8. Now, 8 does not go in nicely into 44, so what we're going to do is we're just going to simplify this fraction. 4 goes in the numerator 11 times, 4 goes in the denominator twice, so that's 11 halves. The next one, add 2 to both sides. We have 8x equals negative 40, so x equals negative 5. So there's your 2 solutions to that one. Next one, I'm going to get 2 solutions also, because whatever is on the inside can be equal to 2, or whatever's on the inside can be equal to negative 2. All right, solving the first equation, subtract 6 from both sides. We have 2/3 x is equal to negative 4. And then to get rid of that 2/3, I'm going to multiply by the reciprocal, which is 3/2. So multiply this side by 3/2, and then multiply this side by 3, divide by 2, right? That's multiplying by 3/2. So we have x equals negative 12 divided by 2 is negative 6. Over here, subtract 6 from both sides. 2/3 x is equal to negative 8. And then multiplying by the reciprocal, multiply by 3, divide by 2. And we have x equals negative 12. So there's your 2 solutions there. Next one here, so I have to get it equal to 16. So the inside is either going to be 16 or the inside is going to be negative 16. Solve each one of those, subtract 10 from both sides. We have negative 3/4 x is equal to 6. Multiply by the reciprocal, which is negative 4/3. Multiply by negative 4/3. So we have x equals, get my blue marker back here. Negative 24 divided by 3 is negative 8. And then here, subtract 10 from both sides. We have negative 3/4 x is equal to negative 26. And then same thing, multiply by the reciprocal, multiply by negative 4, divide by 3. Multiply by negative 4, divide by 3. Negative over negative is a positive. 24 times 4, that's 52/104, which is not simplifiable. So I'm just going to leave it as 104 over 3. So there's your 2 solutions. All right, moving on to the next one right here. I have whatever's underneath this absolute value has to be equal to negative 36, but then I go pause time out. Doesn't matter what I plug in there. Once I take the absolute value, it's not going to be negative 36. It's not going to be negative anything. So I know that this has no solution. Now, if I would solve this algebraically, I will get extraneous solutions that do not work. When I plug them back in, they're going to give me positive 36. But if I think before I do, I can save myself some time. All right, so we looked at ones that the absolute value is already isolated, but what if the absolute value is not isolated? So in this example, the absolute value, which is right here, is not isolated. So what we have to do is we have to get it isolated. So we're going to add 3 to both sides in this problem. So we're going to do plus 3, plus 3. So now we have the absolute value of 2x plus 6 is equal to 16. Now it's isolated. It's just like what we were doing. You're going to split it into 2 equations. Whatever's in there can be 16, but whatever's in there can also be negative 16. And then you're going to solve each of those. So subtract 6 from both sides, divide by 2. You get x equals 5. And on the next one, subtract 6 from both sides. 2x is equal to negative 22. Divide by 2, and you get x is equal to negative 11. Check your solutions back in the original. Plug in a 5. Here I get the absolute value of 16, which is 16. 16 minus 3 is 13. That works. And then plugging in negative 11, we get negative 22 plus 6, which is negative 16, but the absolute value of negative 16 is positive 16. 16 minus 3 is 13. So both of those solutions have been checked. Okay? All right, so I didn't realize it done. The last 2 slides are you trying problems on your own. So go ahead, pause the video and try those out, and then I'll show you the answers. If not, you can compare them with the answer key that's in Schoology also. So here's the first set. And pause the video if you want to check them. And then here is the second set. Notice on 9, 10, and 11, I said no solution, but not because I saw a negative on one side of the equation. Like on this one, in my head, I said, all right, there's a negative there. I'm gonna end up subtracting 7, which still makes it negative. I'm gonna multiply it by 11, still gonna be negative. I'm gonna divide by 5, still gonna be negative. So I like walked through that in my head. For number 11, same thing. I'm gonna subtract 4, that's negative 13. I'm gonna multiply by 8/5, that's still a negative value. So I said no solution, okay? All right, that's it. Go ahead and get started on some homework.